Thank you very much. This will be very low tech. Um, we're trying to get across some of the basic concepts of maintenance to people that might be in marketing or might be in um, uh, IT that just don't know the basics. So that's what this talk is about. I'm just going to go through this. So the problem is we have this manufacturing company, which makes widgets, of course. And the problem is that there's profit pressure and customer complaints, excessive breakdowns, and there's a motivation gap with within the teams that are actually making this stuff. So the board meets and they decide to hand the problem off to a new guy. Um, this is how some people get to have experiences. They get dropped into these kind of places. So the new guy, meets with his team, and we have a sales manager, a maintenance manager, engineering, IT, finance, and operations managers, and ask them, this is a mess. What can we do? And I'd like to remind everyone that in the maintenance world, we're in a battle against entropy, which is the gradual decline into disorder. And we will always lose that battle eventually. What we're trying to do is to win the battle long enough to get the value out of the rail car or the refinery. So we go to each of these people. Each person in your company has a point of view about what the issue is and what the solution is. And, production manager wants new machinery. Finance manager feels that everything should be offshored. And, that would be the best solution to this problem. The sales manager wants a bigger warehouse and more production. The engineering manager wants the coolest IT, industrial Internet of Things, industry 4.0 and sensors and everything else so that she can tell everything that's going on inside the asset. The IT manager wants a new CMMS and make it talk to everything else. And so the maintenance manager is sitting there and listening to all this. And the plant manager asks, what's your opinion? So the maintenance manager says that all of these solutions are good solutions. The problem is time and investment. New machines, offshoring, new buildings, Industry 4.0, new CMMSs, all good solutions, all proven, but they take years and hundreds of thousands of dollars. So what she wants to do is a very low tech solution. She wants fast results with TLC, where we're going to attack the enemies of reliability directly. So I invented a VR lab so I could show you what's going on. So everybody's going to now suit up and get their avatars and go into the lab. We're now going into virtual reality. So in the upper left, we see this is a gearbox that's been giving us problems, and we enlarge the gearbox so it's now, bigger than life. And we can now start to see, in the individual bearings, there's breakdowns. You can see that the clearance between the ball and the race is way smaller than a typical piece of dirt. So the dirt, clumps up in there and creates heat, and it, if the dirt is hard, like like aluminum oxide, it's extremely hard, so the ball can't crush it. What it'll do is it'll jump over it. So it creates, as you can see in the right side on the bottom, um, vibration, thumping, and so we now have heat being created, vibration being created, and dirt being created. So enemy number one is bad friction. And when you enlarge something, you can see that what looks like a smooth surface is actually a rough surface. And when that, rubs directly against another surface, it creates dirt, like sandpaper would create dirt, and heat. And it takes a lot of energy to move it. So we put in oil and grease to minimize the friction. So bad friction is enemy number one. Enemy number two is heat, and heat is from bad friction, from electrical resistance, and from process heat. Enemy number three is looseness, and this is, as opposed to bad friction, this is good friction. It locks things together. Remember, the things are not smooth, they're rough. So when you clamp them, they stick together, and the things can't move in relation to each other. Um, so that locks things together. Looseness, which is enemy number three, is allows things to move. And in electrical connections, it allows corrosion to get between the contact and the wire. And, as you know, that causes heat and possibly fire. The fourth one is dirt. As we talked about, dirt makes heat, and dirt also acts as an insulator. It also obscures what you're looking at, so you can't really see it. It makes repairs unsafe. It lowers the feeling of ownership, and it makes repairing machines undesirable for maintenance, and cleaning is undesirable for operations. So those are our four enemies. Those are the things, there's lots of reasons why our equipment fails, but when you boil it down, you get to one of these four enemies many times. So here we're going to unleash the Kraken, the powerful minds of the team, and we're going to get small teams of maintenance, operations, and other interested parties to work together. And there's going to be three groups. One of them is going to work on tightening, one of them is going to work on lubrication, and one of them is going to work on cleaning. And we're looking for micro projects. These are things that people can do themselves. They don't need huge amounts of money or super long lead times. These are things that can be done very quickly. So the micro project, there's simple rules. One is it should be really, really inexpensive to do. It should use the inventory, tools, and expertise that's already there. It should have a high probability of success and be easy. So we got together and the teams met, and they made 6 little projects to try to move the needle on reliability by addressing the 4 enemies. So the tightening group, when you go through and check the torque on bolts in a factory or in a machine, in a truck, in a train, you find that a lot of them, and this is, from research, a lot of them are not torqued correctly. A lot of them are loose. Maybe 20% are loose. Some of them are too tight, but what this team did was they went through the area of the plant, they torqued all the bolts to the proper reading, and they scribed a line through the bolt nut and frame after torquing. And they added to the PM, they added an inspection for the unbroken line. Now that is not expensive. I mean, in a huge plant, it could take some time to get to all the bolts, but if you just took it in an area, it's extremely effective at dealing with some very common failure modes. And it's like a no-brainer. So the two things that they did, they one torqued the bolts. The second thing is they scribed a line. Now the lubrication folks had two little projects also. This is really interesting. I didn't really know this. They found that the oil drums were stored outside. Now, I'd never really thought about this, but what happens is when the drum is hot during the day, it gets heated up, everything inside of it expands and a little bit of air gets puffed out of the bunghole. And when it gets cooler, the oil in it contracts a little bit and then sucks in anything that's right around the bunghole. So you get this breathing thing, and particularly in areas of the world where there's a gradient in temperature between daytime and nighttime, it literally draws in contamination. And we found that new oil that was left outside, when you looked at it compared to the SAE allowable contamination, it was 15 or 20 times more contaminated than it should have been. So they decided to move the drums immediately inside. They then tested everything and found that even stuff that was inside some of it was contaminated. So they decided to buy a filter cart and like a kidney filter, bypass filter. They filtered all the oil before they put it into their machinery. So if we think back to the virtual reality, you remember all that dirt that was in the oil. Well, we're going to start seeing where that dirt comes from. The second project they did was, again, really simple. Those automatic lubricators, they picked them for areas that were remote and not easily accessible, because they found that you could have like a bunch of fittings and they get greased pretty reliably, but there's one up there, in the ceiling, that you have to climb for, you have to get fall protection for. It's a major pain, and it just doesn't get greased. And they found they were having some problems from that. So they put in some of those oilers and they added them to the PM task list to make sure they were looking at them appropriately at a cadence that would catch them when they ran out or had other problems. So here we have 4 little projects, the 2 from the Titan people, 2 from the oil people. All of them are going to reduce, directly impact the failure modes that are most common. And the last one is, it's also amazingly simple. They called it the clean machine, and they set out workstations for cleaning circ fittings, oil cups and tanks, the tops where, you just clean it before you do the lubrication and clean it afterwards. And that was the project. And they got, people were actually using the materials. So people were, they publicized it and they made banners up and stuff. But it was just the simple thing of, wiping a fitting off before you put lubricant in it. Anybody in the a mechanic in the old days would know that, but now the pressure is on to get production out. So some of that's fallen by the wayside. The second thing was that one of the best solutions to dirt is to catch it at it where it is created. In other words, if you can figure out where the dirt is coming from, if you can catch it there, it's much less expensive to deal with it there than it is inside the machine and the bearings and everything else. In buildings, it's funny. The rule of thumb we use for buildings is if you can catch people's dirt when you walk in the building through carpeting and the slats and stuff, it costs about $1 a pound to get rid of. But once it gets into the carpets through the building, it's about $50 a pound to get rid of. This is a very similar kind of thing. They have a grinder. They decided to put, they had a dust collector that they weren't using. So they went to the output of the side of the grinder and just sucked everything up. And of course, they have to watch out for introducing any hazards from the dust, from the collection of the dust, from static electricity. But the point was, it was like a no-brainer because they had the equipment. They just wanted to see if it would work, and they were very happy about that. Now, the toughest part of this, obviously, is going to be sustaining the program. And the model that I'm using here is what's called the ProSci model, which is when you're making a change in an organization, you want to make sure everybody's aware of what you're doing and why you're doing it. The second thing is to create a desire on the part of other people that they're interested in this and they see something for themselves in what you're doing. So they see that it'll make it cleaner or it'll be better to work there or something. We then have to give them knowledge, and we have to give them all the tools that they need, the access, the cleaning tools, the space for the drums inside. And then finally, we have to keep reinforcing the messages. So that's how we go about sustaining a change in an organization. They call it their ADKAR model. So I want to thank you very much for this short talk. This is all about victory over entropy. So I want to thank you for listening. And this is a comic book. These pictures are from the comic book to try to communicate this in a fun way to some of the younger people. So thank you very much.
Thank you, Mr. Levitt, for that wonderful talk. Audience, if you have any questions, you can put it in the chat box. Okay, one question from Mickey. The biggest challenge of CISD team is a people retention. What is your best practice regarding this issue?
Well, it's interesting. All these kind of things are dependent on having people there for a while. And one of the things that I think that we arrive at is when you start taking care of the equipment better, and it's obvious to people that the morale actually goes up and the feeling of ownership of the equipment goes up. Now, this is not going to solve the problem if it's a bad environment, but this can provide a reason for people to stick around. Remember, when we do these little teams, people are going to get to do things that they don't normally do, learn things that they don't normally learn, and that tends to make people more enthusiastic about their work situation. Now I see this next question. So I'm not a doctor. So the professor was a doctor. Just a person. Okay. Um, it's really important that these issues are dealt with by the people on the front lines, both in operations and in maintenance, and maybe some other areas. So I like them to work together. I like them to, you know, we first thought that, there would be blood drawn if the operators and the maintenance guys got in the same room, but it turns out that they all hated the finance people even more than each other. So that worked out really well. Um, I'm just reading this. Assist engineering staff with full support from their side as well. Um, I just have to pull this down. So this is a little bit more detailed. If you want to ask me this, I'd be happy to answer that by email. What is the best way for preventive maintenance in general? Um, well, preventive maintenance is there's a, kind of a famous person here in Philadelphia. I'm in the States right now. Um, he was in a department store, and he said that he knew that half of his advertising was wasted, but he didn't know which half. And I think that is completely the same for preventive maintenance, is that we know that most of it is wasted, but we don't know which stuff is not wasted. So the best practice for me for preventive maintenance in general is, there's rigorous ways of developing tasking, but there's also practical ways to develop tasking. And I'm a believer in let the engineers do the RCM and the rigorous stuff, but let the people that are doing the work design the system or elements of the system. And I like to, when I do consulting assignments, I'll follow somebody and just chat with them and just see what's in the way of them doing it be easier for them. And I encourage people to do that because these people on the ground, um, it's really funny, but these people are just as smart as the people with the schooling and the degrees and stuff. They just didn't do that. So they know a lot. They know more about the failure modes than anybody because they're the ones that have to shovel the crap, to get to the thing because it broke and everything went all over the place. So if I said one thing, it's let the people who are on the ground design elements of it and listen to what they say and don't put it off, like don't just push it away. Listen to what they say and if you can, implement it. Now, is it possible to implement predictive maintenance in any company? This is interesting because predictive maintenance requires a certain sophistication and analysis. So, yes, the answer is absolutely yes, but maybe the way to do it is to have a contractor who has that requisite knowledge just give you work orders. If we go back to the last presentation, uh, prescriptive maintenance is when the analytics looks at the data and comes up with an action and generates a work request in the work order work management system. Well, you could do the same thing with a contractor if you didn't have the expertise, that they go all the way to the point of writing the work request and putting it in the system, and then it gets treated with all the rest of the work requests. That way you could start it right off the bat and not have the big problem of, the learning curve that could be quite long for some stuff like vibration. Uh, what is a critical point of defining maintenance strategy? Okay. The way I approach this, and it may be different than the way other people do, is I really look at the mission of the organization, what they're trying to do, what they're, why they exist even, and then look at the assets and the risks that they naturally have, and build the strategy off of their mission and the risks we're trying to avoid. You know, a lot of stuff we're trying to avoid is just not hurting the employees, the public, the environment, you know, just trying to not do damage. And preventive maintenance strategies, a lot of them are around that, for the hazards and for health problems and everything else. So I look at the mission. What is the mission? What, like, you know, if you run a train system, you got to work it on time. It's got to be safe, and then build a maintenance strategy that services that. Now, the last presentation was fabulous in the way it pointed out asset criticality, because those red ones, those like 9 assets that were over in the red part, you know, they would take the most sophisticated and rigorous methods. The stuff that's like on the other end that was really not critical, that can use almost any method. Even run to failure might be a legitimate choice in that kind of thing.